Welcome, everyone. Today, we're diving into something that might challenge how you think about mental health and psychological disorders. You see, when most people hear abnormal psychology, they think broken, diseased, malfunctioning. But what if I told you that some of what we call abnormal might actually be your brain doing exactly what it evolved to do, just in the wrong context? Think about it this way. Have you ever felt anxious before a big exam or presentation? That's not your brain malfunctioning. That's an ancient alarm system that kept your ancestors alive when they faced real threats. The problem is, your brain can't always tell the difference between a saber-toothed tiger and a statistics final. This course takes an evolutionary psychology perspective, which means we're going to ask not just what's wrong, but why might this have made sense in our ancestral past? We'll explore how ancient adaptations meet modern challenges and why understanding our evolutionary history might be the key to understanding mental health. This doesn't mean we're excusing harmful behaviors or saying disorders aren't real. Quite the opposite. We're adding a deeper layer of understanding that can inform better treatments. So buckle up. We're about to look at the human mind through a lens that spans millions of years of evolution. Let me introduce you to the evolutionary psychology framework, which is going to be our roadmap for this entire unit. Now, I know some of you might be thinking, great, another theory to memorize, but stick with me. This one actually ties everything together in a way that makes sense. First, let's talk about proximate versus ultimate causes. This is crucial. When someone is depressed, the proximate cause might be a serotonin imbalance. That's the immediate mechanism, the how. But the ultimate cause asks why. Why do humans even have the capacity for depression? Why would natural selection preserve something that seems so harmful? Maybe depression served a function in our ancestral past, perhaps as a signal to withdraw and reassess when social strategies weren't working. Here's where it gets interesting. Evolutionary psychology gives us several ways to understand psychological disorders. Some might be adaptive responses that become maladaptive in new contexts, like our love of sugar and fat, which made perfect sense when food was scarce but leads to obesity in modern environments. Others might be trade-offs. The same genes that give us creativity might also predispose us to schizophrenia. Some are byproducts of complex cognitive evolution, and others result from mismatch between our ancestral environment and today's world. The key insight? Natural selection shaped our minds to solve survival and reproductive challenges in ancestral environments, not modern lecture halls, office cubicles, or social media feeds. Understanding this mismatch is essential to understanding modern mental health. So how do we actually determine what counts as abnormal? This is trickier than it sounds, and there's no single answer that works in all cases. Let's walk through 5 traditional approaches. First, statistical deviation. This seems straightforward. If most people are between 4 inches and 6 and 2, then someone who's 7 feet tall is statistically abnormal. But here's the problem. Statistical rarity doesn't equal disorder. Having an IQ of 150 is statistically rare, but we don't call that a disorder. We call it gifted. So statistical deviation alone isn't enough. Second, deviation from ideal, basically violating social norms. But whose norms? In some cultures, hearing the voices of deceased ancestors is considered a spiritual gift. In Western psychiatry, it might be labeled as a hallucination. Cultural context matters enormously. Third, personal distress. This one seems more solid. If you're suffering, something's wrong, right? But what about people with antisocial personality disorder who feel no distress about harming others? Or people in manic episodes who feel fantastic while making terrible decisions? Fourth, inability to function. Can you hold a job, maintain relationships, take care of yourself? This is practical, but it's also culturally dependent. What counts as functioning varies widely across societies. Finally, there's the legal definition of insanity, which is really about whether someone knew right from wrong at the time of a crime. This is a legal construct, not a psychological one. The bottom line? No single definition captures everything. We need multiple perspectives, which is why the evolutionary approach we're taking adds such valuable context. Now let's talk about the DSM-5, TR, the Diagnostic and Statistical Manual of Mental Disorders, 5th edition, text revision. This is the Bible of psychiatric diagnosis in the United States. Published in 2022, it's the most current version, and if you go into clinical psychology, psychiatry, counseling, or social work, you'll become very familiar with this book. The DSM organizes mental disorders into major categories. You've got neurodevelopmental disorders like autism and ADHD that typically emerge in childhood. Anxiety disorders, JD, panic disorder, phobias, these are among the most common. Mood disorders include depression and bipolar disorder, trauma and stress-related disorders like PTSD, schizophrenia spectrum disorders involving psychosis, personality disorders like borderline and antisocial, OCD and related disorders, and dissociative disorders. The 2022 text revision updated diagnostic criteria for over 70 disorders and expanded information on how culture, gender, race, and ethnicity influence diagnosis and presentation. This is important. Mental health doesn't look the same across all populations. But here's the critical thing to understand. The DSM is atheoretical and descriptive. It tells you what symptoms cluster together to form a diagnosis, but it doesn't tell you why. It's like a field guide to birds that describes what they look like but doesn't explain why they evolved those features. The DSM gives us a common language for diagnosis, which is valuable for communication and research, but it's not an explanation. That's where frameworks like evolutionary psychology come in, to provide the why behind the what. Let's take a quick tour through the major categories of psychological disorders you'll encounter in clinical practice. I'm not going to go deep into each one right now. We'll cover many of these in detail later, but I want you to see the landscape. Anxiety disorders are incredibly common. About 30% of people will experience one in their lifetime. These include generalized anxiety disorder, where worry becomes chronic and uncontrollable, panic disorder with sudden intense fear attacks, social anxiety disorder, specific phobias, and agoraphobia, which is fear of situations where escape might be difficult. OCD and related disorders involve intrusive thoughts and repetitive behaviors. Body dysmorphic disorder involves obsessive focus on perceived physical flaws. Hoarding disorder, yes, that's now its own diagnosis. And trichotillomania, which is compulsive hair pulling. Mood disorders include major depressive disorder, which we'll discuss extensively, and bipolar disorders involving mood swings between depression and mania. These are among the most debilitating conditions. Trauma and stressor-related disorders like PTSD occur after exposure to traumatic events. These are particularly interesting from an evolutionary perspective because they involve the brain's threat detection system getting stuck in overdrive. Schizophrenia spectrum disorders involve breaks from reality, hallucinations, delusions, disorganized thinking. These are less common but severe. And personality disorders involve enduring patterns of behavior that deviate from cultural expectations and cause distress or impairment. Here's something important. Comorbidity is the rule, not the exception. Most people with one disorder have at least one other. Depression and anxiety commonly occur together. PTSD often comes with depression. This clustering tells us something important about how these systems are interconnected. Now let's talk about what the DSM doesn't tell us, its limitations. This is important because students often think that once you have a diagnosis, you understand the disorder. Not quite. First, the DSM is atheoretical. It groups disorders based on symptoms that statistically cluster together, but it provides no underlying theory explaining why these symptoms occur together or what causes them. It's like organizing books by color instead of by subject. You can do it, but it doesn't tell you much about the content. Clinicians can label a condition, but may not understand its root causes. Second, there's no consensus on causes or treatments. Different theoretical orientations, psychodynamic, cognitive behavioral, biological, humanistic, offer competing explanations for the same disorders. One therapist might see depression as repressed anger, another as distorted thinking patterns, another as a chemical imbalance. They're all looking at the same elephant from different angles. Third, labeling without understanding. Assigning a diagnostic label can create an illusion of understanding without actually explaining anything. It's like saying someone has a fever because they have fever disorder. The label describes the symptom but doesn't explain the cause. Plus, labels can lead to stigmatization and don't necessarily predict outcomes or guide treatment effectively. This is why we need integrative theoretical frameworks like evolutionary psychology. It doesn't replace the DSM, we still need that common diagnostic language, but it adds a layer of explanation. It helps us understand not just what the symptoms are, but why humans have the capacity for these symptoms in the first place. Diagnosis is a starting point, not the finish line. All right, now we get to the heart of our approach, understanding abnormality through evolutionary psychology. This framework rests on several core principles that I want you to really grasp. First, natural selection. Traits that enhance survival and reproduction in our ancestors were more likely to be passed on. This is basic Darwin, but it's crucial. Our brains aren't randomly designed, they're the product of millions of years of selection pressures. Second, adaptive design. Our psychological mechanisms evolved to solve specific ancestral problems. We have a fear module because ancestors who feared snakes and heights were more likely to survive. We have attachment systems because infants who bonded with caregivers survived. These aren't arbitrary, they're functional designs. Third, the environment of evolutionary adaptedness, or EEA. This refers to the ancestral environment that shaped our adaptations, roughly the Pleistocene era when we lived in small hunter-gatherer groups. This is the environment our brains are designed for. And fourth, the mismatch hypothesis. This is huge. Modern environments differ dramatically from our evolutionary past, and this causes dysfunction. We evolved to crave sugar, salt, and fat because they were scarce and valuable. Now they're everywhere, and we have obesity epidemics. We evolved to live in groups of 50, 150 people, and now we're trying to navigate social networks of thousands. Our brains are running Stone Age software in a Space Age world. So when we look at abnormality through this lens, we ask, is this a functioning adaptation in the wrong context? A byproduct of another adaptation? A malfunctioning system? An alternative strategy? An environmental mismatch? Or just normal variation? This framework doesn't excuse harmful behaviors, it explains origins. And understanding origins can guide better interventions. This table is your conceptual toolkit for the rest of the course, so let's break it down carefully. We're looking at 7 different ways something can be abnormal from an adaptationist perspective with both physiological and psychological examples. First, functioning adaptations. These are adaptive defenses. Fever is unpleasant, but it helps fight infection. Similarly, depression and anxiety might be unpleasant, but functional responses to certain situations. We'll explore this idea extensively. Second, byproducts of adaptations. Your belly button serves no function, it's just a byproduct of umbilical cord attachment. Similarly, some psychological phenomena might be byproducts. Sexual fetishes might be byproducts of normal attraction mechanisms gone slightly off track. Attention deficit might be a byproduct of cognitive systems designed for different environments. Third, genes with multiple effects. The gene for malaria resistance causes sickle cell anemia. One gene, multiple effects, some good, some bad. Similarly, genes for creativity and cognitive flexibility might predispose people to schizophrenia or bipolar disorder. You can't get the benefits without the risks. Fourth, malfunctioning adaptations. Allergies are your immune system overreacting to harmless substances, a malfunction. Autism might involve a malfunctioning theory of mind module that normally helps us understand others' mental states. Fifth, frequency-dependent morphs. Having 2 sexes is an example, both are normal variations. Similarly, different personality types might be alternative strategies that are all viable. Even personality disorders might represent extreme versions of strategies that work in certain contexts. Sixth, mismatch between ancestral and current environments. Eating too much sugar made sense when it was rare, now it causes obesity. Similarly, our stress responses are calibrated for acute physical threats, not chronic psychological stressors, leading to generalized anxiety and depression. Finally, the tail of the bell curve, statistical extremes. Very short or tall height, extremely introverted or extroverted. These are just normal variation. The key insight? Abnormal doesn't have one meaning. Context matters. Let's directly compare traditional psychiatric approaches with the evolutionary approach. I want to be clear, evolutionary psychology complements traditional treatments. It doesn't replace them. We still need medication, therapy, and all the tools of modern psychiatry. But the evolutionary perspective adds something valuable. Traditional psychiatry lacks an integrating theory. You've got psychodynamic theory, cognitive behavioral theory, biological psychiatry, humanistic approaches, all competing frameworks with no unifying structure. It's like having multiple maps of the same territory that don't agree with each other. Traditional approaches also sometimes confuse mad and bad, conflating moral judgments with mental illness. Is antisocial personality disorder a mental illness or just being a jerk? The line gets blurry. The traditional broken machine metaphor views mental health as a machine that suddenly fails. But brains aren't machines, they're evolved organs with functional designs. The possession metaphor in insight therapy suggests something foreign has invaded you, which isn't quite right either. And traditional classification is descriptive, not explanatory. It tells you what symptoms look like, but not why they exist. In contrast, the evolutionary approach provides a unified theoretical framework based on natural selection. It separates a behavior's adaptive function from moral judgment. Understanding why something evolved doesn't mean approving of it. It views the mind as functionally designed to solve adaptive problems, not as a machine that breaks randomly. It offers multiple causal categories, mismatch, byproduct, malfunction, etc., giving us a richer vocabulary for understanding disorders. And it explains both proximate causes, how it works, and ultimate causes, why it exists. Again, this isn't either or. The best approach integrates evolutionary insights with evidence-based treatments. Understanding the why can make the how to treat more effective. Now let's apply this evolutionary framework to depression, which affects about 20% of people at some point in their lives. I'm going to propose something that might sound counterintuitive. What if mild depression serves a function? Think about fever. It's miserable, right? You feel awful. But fever is an adaptive defense that helps fight infection and speeds recovery. Unpleasant doesn't equal maladaptive. The discomfort is part of the solution, not just the problem. Could depression be similar? Could it be an evolved response to threatening situations that prompts behavioral change and reassessment? Let's consider the potential adaptive functions of mild depression. First, behavioral inhibition. Depression slows you down, reduces activity and risk-taking. If you're in an unfavorable situation, say you've lost status in your social group, taking risks might make things worse. Slowing down and conserving energy might be adaptive. Second, depression promotes rumination, intense repetitive focus on problems. We usually think of rumination as pathological, but it might facilitate deep analysis and realistic assessment. Mildly depressed people actually show more accurate judgments in some studies. They're less subject to positive illusions. Third, depression signals need for support. Visible distress communicates to others that you need help, potentially mobilizing social support. In ancestral environments, social support was crucial for survival. Fourth, depression forces reassessment. When your current strategies aren't working, you've lost a job, a relationship has failed, depression might force you to reevaluate your goals and life direction rather than persisting in failing strategies. Research by psychologists like Paul Andrews and others shows that mildly depressed individuals can make more accurate judgments and have more realistic self-perceptions than non-depressed people. Now, here's the critical caveat. This model applies to mild depression. Severe clinical depression is a debilitating illness that absolutely requires treatment. The fact that mild sadness might serve a function doesn't mean severe depression should go untreated. It's like saying mild inflammation helps healing. That doesn't mean sepsis is good for you. Context and severity matter enormously. Here we see neurological evidence of depression through PET scans comparing brain activity in non-depressed versus depressed individuals. These images show metabolic activity, essentially how much energy different brain regions are using. In the non-depressed brain on the left, you see high metabolic activity throughout cerebral regions, particularly in the frontal lobes and limbic system. These areas are actively processing information, regulating emotions, planning and executing behaviors. In the depressed brain on the right, you see significantly reduced metabolic activity, especially in the prefrontal cortex. This correlates with the behavioral slowing and cognitive changes we see in depression: reduced motivation, slowed thinking, difficulty concentrating, and decreased activity levels. Now here's where the evolutionary perspective adds insight. Is this reduced brain activity simply a malfunction, or could it reflect adaptive energy conservation? Remember our discussion from the previous slide about depression potentially serving a function. If depression evolved partly to conserve energy during unfavorable circumstances, we'd expect to see exactly this pattern, a metabolic slowdown. Think about it. If you're in a situation where active problem solving isn't working, where resources are scarce, or where you've lost social status, ramping down metabolic activity might be adaptive. It's like your brain going into power saving mode. Of course, this doesn't mean severe depression is adaptive or should go untreated. These scans show us that depression involves real, measurable changes in brain function. But understanding that these changes might reflect an evolved response, even if it's misfiring in modern contexts, can inform how we think about treatment. We're not just fixing a broken brain, we might be helping recalibrate a system that's responding to perceived threats or losses. This is the power of integrating neuroscience with evolutionary psychology. We get both the mechanism and the potential function. These are actual images of fMRI scans for people who are depressed, on the left, compared to brain scans of people who are not depressed, on the right. You can clearly see that the brains of depressed people are less active. Let's look at specific situations that reliably trigger depressive responses. If depression is sometimes an adaptive response, we'd expect it to be triggered by specific ancestral problems. And that's exactly what we see. First, postpartum depression affecting 10 to 20% of new mothers. From an evolutionary perspective, this might signal a need for help and encourage staying close to support systems. Raising an infant alone was nearly impossible in ancestral environments. Postpartum depression might mobilize social support by signaling distress. This doesn't mean it's not serious or shouldn't be treated. It absolutely should, but understanding the function helps us understand why it exists. Second, loss of a partner or family member. Bereavement is one of the most common triggers for prolonged depression. Evolutionarily, this prompts reassessment of social strategies and signals need for support. You've lost a crucial relationship. Your brain is telling you to slow down, reassess, and seek help. Third, job loss or status decline. Unemployment and loss of social status are major depression triggers. In ancestral environments, status was crucial for survival and reproduction. Depression in response to status loss might prompt strategic withdrawal to reconsider your approach rather than continuing to fail publicly. Fourth, romantic rejection. Relationship loss and infidelity strongly correlate with depression. This might facilitate disengagement from failing relationships so you can eventually make better choices. It's painful, but it prevents you from continuing to invest in relationships that aren't working. Finally, seasonal affective disorder, or SAD, where depression correlates with reduced daylight in northern latitudes. This might be an adaptive response to conserve energy during winters when resources were historically scarce. In ancestral environments, winter meant less food, harsher conditions, and higher mortality. Slowing down metabolically might have been adaptive. Notice a pattern? These aren't random triggers. They're all situations that would have posed serious adaptive challenges to our ancestors. Loss of social support, loss of status, loss of reproductive opportunities, and resource scarcity. Our brains are responding to these situations with an evolved response that might have been adaptive in ancestral contexts. Understanding this evolutionary context doesn't mean we shouldn't treat depression. We absolutely should. But it helps frame treatments that work with our psychology rather than against it. It suggests that addressing the underlying adaptive problem, rebuilding social support, finding new sources of meaning and status, addressing resource insecurity, might be as important as addressing neurochemistry. Now let's dive into one of the most fascinating puzzles in evolutionary psychology, the depression paradox. Now I want you to think about this for a moment. If depression is so costly, reducing both fitness and increasing mortality, why on earth would natural selection keep it around? It's like asking why we'd keep a broken tool in our evolutionary toolkit. Here's what makes this truly mind-bending. Depression has a heritability of 40 to 50%, meaning genetics play a huge role. And we're not talking about a rare condition. Over 300 million people globally are affected. So natural selection has had plenty of opportunities to weed this out, yet here it is, persisting across all human populations. Let me walk you through 3 leading hypotheses that attempt to solve this puzzle. First, there's the analytical rumination hypothesis. Think of depression as your brain's way of forcing you to sit down and really think through a complex problem. When you're depressed, you withdraw from social activities, you lose interest in distractions. Essentially, your brain is conserving energy and directing it all toward analysis. We see increased prefrontal cortex activity during depressive episodes, and some studies show enhanced problem-solving abilities. It's like your brain is saying, we have a serious problem here, and I'm shutting down everything else until we figure this out. Second, we have the social risk and honest signaling hypothesis. Depression might act as a credible signal of distress. Think of it as a biological white flag. When you're genuinely depressed, you can't fake being okay, and this honest signal elicits social support from others. It can also help de-escalate conflicts because your depressed state signals that you're not a threat. The evidence shows that people do respond to depressive signals with increased social support. Finally, there's rank theory and the concept of psychic pain. This is particularly interesting. Depression may function as an involuntary defeat strategy. When you're in a social conflict you can't win, depression forces you to concede, to withdraw, to conserve your energy rather than continuing a losing battle. We see this pattern across species in social defeat scenarios. It's painful, yes, but it might prevent even more costly continued conflict. So the question isn't just why does depression exist, but rather what adaptive problems might it have solved? Keep these hypotheses in mind as we explore how modern environments might be triggering these ancient mechanisms in maladaptive ways. Now let's talk about how our modern world might be creating a perfect storm for depression. This is where the mismatch hypothesis really shines. I want you to imagine what life was like for our ancestors, and I'm talking about the environment in which our brains evolved over hundreds of thousands of years. In the ancestral environment, you lived in small groups of maybe 25 to 150 people, your extended family and tribe. You knew everyone and everyone knew you. Your social relationships were stable and lifelong. When you had a problem, your biological relatives were right there to support you. Your social role was clear, the hierarchy was visible and understandable, and you rarely encountered strangers. Now contrast that with modern life. We live in massive anonymous societies. How many of you have neighbors you've never spoken to? Our relationships are often transient. People move for jobs, friendships fade when someone leaves social media. Social isolation is incredibly common despite being surrounded by millions of people. And here's a kicker. We're constantly comparing ourselves to people at the very top of massive hierarchies. You're not comparing yourself to the best hunter in your tribe of 50 people. You're comparing yourself to billionaires, celebrities, and Instagram influencers with millions of followers. Think about what this does to our evolved psychology. We're forced into constant vigilance around strangers. Your threat detection systems never fully relax. Older adults often feel like burdens to their families, rather than respected elders with crucial knowledge. The social support mechanisms that would have buffered against depression in ancestral environments simply aren't there for many people today. This is mismatch in action. The same mechanisms that might have been adaptive, withdrawing when you've lost status, signaling for social support, are being triggered constantly by modern conditions they weren't designed to handle. It's like running software designed for one operating system on a completely different one. The code isn't broken, it's just in the wrong environment. Does this mean we should all go live in small tribes? Of course not. But understanding this mismatch helps us see that the problem isn't just broken brains. It's also about the profound disconnect between the world we evolved for and the world we've created. Let's shift gears to anxiety, which is actually one of my favorite topics because it so beautifully illustrates the difference between an adaptation and a disorder. Show of hands, how many of you have experienced anxiety? Keep them up. Now, how many of you are glad you have the capacity to feel anxiety? Probably fewer hands, right? But here's the thing, anxiety is fundamentally a survival mechanism. It's your brain's threat detection system, and it operates on what we call the smoke detector principle. Think about your smoke detector at home. Would you rather it be too sensitive and go off when you burn toast, or not sensitive enough and fail to alert you to an actual fire? Obviously, you want it oversensitive. The cost of a false alarm, waving a towel at your smoke detector, is trivial compared to the cost of missing a real fire. Evolution designed our anxiety systems the same way. Better to be anxious about a rustling bush that turns out to be wind than to be relaxed about a rustling bush that turns out to be a predator. Our ancestors who had hair trigger anxiety systems survived and reproduced. The chill, relaxed ones became lunch. Anxiety served multiple adaptive roles. It promoted predator avoidance through heightened vigilance. It helped navigate social threats. If you're anxious about offending the dominant member of your group, you're more likely to use de-escalating strategies. It even facilitated reconciliation after conflicts because your anxiety about damaged relationships motivated you to repair them. So when does this adaptive system become a disorder? When it's excessive, disruptive, and impairs your daily functioning. Phobias are a perfect example, an intense, unrealistic fear that's out of proportion to the actual threat. We see specific phobias, social phobias, and agoraphobia, which is the most impairing. And here's a fascinating pattern. Anxiety disorders affect women more than men. Why might that be? Think about ancestral environments. Women, especially pregnant women or those with young children, face different threat profiles than men. A more sensitive threat detection system might have been particularly adaptive for them. The key insight is this: the same system that saved your ancestors' lives is now firing in a world where actual physical threats are rare. Your smoke detector is working perfectly, it's just that someone filled your house with toast burners. Now we get to the heart of the mismatch problem with anxiety. Our ancestral anxiety systems are being absolutely overwhelmed by modern life, and I want to walk you through exactly how this happens. Let's start with information overload. Your threat detection system evolved in an environment where information came from direct sensory experience, what you could see, hear, and smell in your immediate environment. Now, you wake up, check your phone, and within minutes you've been exposed to news about wars, pandemics, economic crises, and climate change from around the entire world. Your amygdala, your brain's threat detector, doesn't distinguish between a threat in your immediate environment and a threat on the other side of the planet. It just registers threat, threat, threat. Then there's the nature of modern threats themselves. Ancestral threats were acute: a predator, a hostile neighboring group, a dangerous storm. These threats demanded immediate action, and then they were over. Modern threats are chronic and abstract. Job security, that's not a one-time threat you can fight or flee from, it's a persistent background stressor. Financial insecurity, climate change, your retirement account, these are threats that never resolve, and your anxiety system doesn't know how to handle that. Consider the social environment. You're navigating vast anonymous populations instead of small kin-based groups. Every day you might interact with dozens or hundreds of strangers. Your vigilance systems, which evolved to monitor a stable group of known individuals, are constantly activated. And here's what's insidious. Your vigilance systems start misfiring and redirecting towards social threats. Social media comparison, fear of missing out, worrying about what people think of your online presence, these are novel triggers for ancient systems. Let me share something really interesting from the research. There's a paradox in the relationship between anxiety and reproductive fitness. Studies tracking multiple generations have found that both very low and very high anxiety can predict more descendants. How can that be? Well, in some contexts, extreme anxiety might offer survival advantages through heightened vigilance. You're the person who notices the danger first, who prepares for the worst-case scenario, who survives when others don't. But here's the cost. That same heightened vigilance increases your risk of developing an anxiety disorder. It's adaptive until it isn't. This is the cruel irony of mismatch. Traits that might have helped your ancestors survive are now making you miserable in a world they never could have imagined. All right, let's tackle autism spectrum disorder, which presents us with a genuinely puzzling evolutionary question. ASD has a heritability of 70 to 80%. That's really high, meaning genetics play a major role. It affects about 1 in 100 people globally, so it's not rare. And here's the puzzle. Individuals with ASD generally have reduced reproductive success and face significant social and communicative challenges. So why does it persist at such relatively high rates? The leading hypothesis is that ASD may be a byproduct of rapid human brain evolution. Think about this. The human brain is an extraordinary organ. It's incredibly complex, uses 20% of our body's total energy despite being only 2% of our body weight, and it's evolved rapidly over the past few million years. That rapid evolution came with trade-offs. Let me introduce you to something called human accelerated regions, or HRs. These are parts of our genome that were highly conserved across mammals for millions of years, but then suddenly evolved rapidly in the human lineage. Many HARs are involved in brain development, and here's the kicker. Mutations in these regions are linked to ASD. The same genes that gave us our remarkable cognitive abilities also created vulnerabilities. There's a concept called neural evolution trade-offs. Some genes linked to ASD actually slowed brain development while simultaneously boosting certain cognitive abilities. It's like overclocking a computer. You get better performance, but you also increase the risk of system instability. The brain's high energy demands and complex development make it particularly vulnerable to disruption. Now let me walk you through 3 theoretical frameworks for understanding ASD. First, there's the extreme male brain theory, which suggests that the focus on systemizing over empathizing, a hallmark of ASD, may stem from traits that were ancestrally advantageous, particularly for males. Think about activities like tracking animals, creating tools, understanding mechanical systems. These require strong systemizing abilities. Second, we have epistatic interactions. That's when certain combinations of genes disrupt development, while other combinations might actually boost intelligence. This could explain why ASD runs in families that also show high intelligence and achievement. Finally, there's the neurodiversity perspective, which I think is really important. This view sees ASD not as purely pathological, but as part of human variation, where cognitive gains are inherently linked to vulnerabilities. Individuals with ASD often show remarkable strengths in pattern recognition, attention to detail, and systematic thinking alongside their challenges. The key insight is that ASD involves trade-offs. It's not just a collection of deficits. It's a different cognitive profile where certain abilities are enhanced while others are impaired. This makes sense if it's a byproduct of the same evolutionary processes that gave humans our unique cognitive abilities. We pushed brain evolution to the edge, and sometimes that edge is where you find both extraordinary abilities and significant challenges. Bipolar disorder presents us with another fascinating evolutionary puzzle, and I have to say, the hypotheses here are particularly creative. Let's start with the basics. Bipolar affects about 1% of the world's population. That's 1 in 100 people across every culture. If one identical twin has bipolar disorder, there's a 70% chance the other twin will have it too. That's a strong genetic basis. And yet, bipolar disorder has high fitness costs. It's associated with reduced reproductive success and increased mortality. So why does it persist? One clue is the link to creativity. We're talking about Van Gogh, Edgar Allan Poe, Virginia Woolf, Sylvia Plath. The list of highly creative individuals with bipolar disorder is striking. Could there be a connection between the genes that predispose someone to bipolar disorder and enhanced creativity? If so, maybe mild forms of these traits actually increased fitness in ancestral environments. But here's where it gets really interesting. There's a hypothesis called the evolutionary origin of bipolar disorder, or EOBDR, that links bipolar traits to Neanderthal adaptations to harsh Pleistocene climates. Stay with me here. This is speculative but fascinating. The idea is that bipolar traits might have been adaptations to extreme seasonal variation. Winter depression would conserve energy during harsh winters when resources were scarce. Summer mania would enable intensive resource gathering during the brief productive season. Crisis mania, risk-taking, and reduced need for sleep might have been crucial for survival during emergencies. This hypothesis makes a testable prediction. Populations without Neanderthal genes should show lower incidence of bipolar disorder. We're still gathering data on this, but it's a great example of how evolutionary thinking generates testable hypotheses. Now let's talk about mismatch. Even if bipolar traits were adaptive in ancestral environments, they can become severely maladaptive in modern contexts. Modern triggers include chronic stress, which disrupts circadian rhythms, and circadian rhythm disruption is huge in bipolar disorder. Poor diet activates inflammatory pathways that disrupt mood regulation. Physical inactivity reduces natural mood stabilization. Disrupted sleep from artificial light can trigger manic episodes. Here's a key mechanism. Chronic inflammation desynchronizes the biological clock. Your circadian rhythms are fundamental to mood regulation, and modern life, with its artificial lighting, shift work, jet lag, and 24/7 connectivity, is constantly disrupting these rhythms. The takeaway is that mild bipolar traits might have boosted creativity and success in ancestral environments, but modern life amplifies these traits into full-blown disorder. It's another example of how our evolutionary heritage interacts with novel environments to produce psychological disorders. Schizophrenia is perhaps the most severe and puzzling of all the disorders we'll discuss. It affects about 1% of the global population, has a heritability of 70 to 80%, and is associated with significantly reduced fertility and increased mortality. If ever there was a condition that natural selection should have eliminated, this would be it. And yet it persists across all human populations at roughly the same rate. Why? Let me start with some historical context. Schizophrenia has often been associated with creativity, though this link is more controversial than with bipolar disorder. There's also the famous case of the Genayan quadruplets, 4 identical sisters who all developed schizophrenia. This case dramatically illustrated the strong genetic component. One hypothesis is balancing selection. The idea is that genes that increase risk for schizophrenia might confer advantages to relatives who carry them but don't develop the full disorder. These advantages might include enhanced creativity or cognitive flexibility. Think of it like sickle cell anemia. Having 2 copies of the gene causes disease, but having 1 copy protects against malaria. Could something similar be happening with schizophrenia genes? I have to be honest with you, the empirical support for a clear fitness advantage is mixed. This hypothesis is controversial, and we don't have strong evidence that relatives of people with schizophrenia have enhanced fitness. The more compelling hypothesis, in my view, is the social brain byproduct theory. Schizophrenia may be an extreme maladaptive outcome of the same complex neural systems that enable uniquely human abilities like language and social cognition. Think about what makes human brains special: our capacity for language, our ability to understand others' mental states, our complex social reasoning. These abilities require incredibly sophisticated neural systems. Here's the evidence. Genes involved in human brain evolution, the ones that changed rapidly in our lineage, correlate with brain regions implicated in schizophrenia. It's as if the same evolutionary changes that gave us language and complex social cognition also created vulnerabilities to schizophrenia. There are other explanations too. Mutation selection balance suggests that new mutations arise too frequently for selection to remove them. Schizophrenia might be maintained by a constant influx of new deleterious mutations. And there's mismatch. Modern environments, particularly urban stress, social fragmentation, and substance use, might trigger genetic vulnerabilities that would have remained dormant in ancestral environments. The most likely explanation is that schizophrenia is a deleterious byproduct of human cognitive evolution. We paid for our remarkable cognitive abilities with increased vulnerability to severe mental disorders. It's a sobering reminder that evolution doesn't produce perfection, it produces trade-offs. Now we're going to explore personality disorders through an evolutionary lens, and this is where things get really interesting because we're going to challenge some assumptions about what disorder even means. Personality disorders can be seen as extreme variants of traits that evolved to solve adaptive challenges. Let me unpack that. Think about personality traits as solutions to adaptive problems. How much should you trust others? How much should you invest in long-term versus short-term goals? How much risk should you take? There's no single correct answer to these questions. The optimal strategy depends on your environment, your resources, and what others are doing. This brings us to several evolutionary concepts. First, life history theory, which is about trade-offs between immediate and delayed reproduction, between quantity and quality of offspring. Second, balancing selection. Different strategies thrive in different contexts, so multiple strategies can coexist. Third, frequency-dependent selection. Some strategies only work when they're rare. And fourth, environmental mismatch. Traits that were adaptive in ancestral environments become maladaptive in modern ones. Let me give you concrete examples. Borderline personality disorder, or BPD, is characterized by impulsivity, risk-taking, unstable relationships, and intense fear of abandonment. From a life history perspective, this looks like a fast life history strategy, prioritizing immediate rewards over long-term planning. This strategy can be adaptive in harsh, unpredictable environments where the future is uncertain. If you don't know if you'll survive to next year, it makes sense to take what you can get now. Antisocial personality disorder, or ASPD, involves exploitative strategies, manipulation, and lack of empathy. This is a classic example of frequency-dependent selection. Think of it as a cheater strategy. If most people cooperate, a few cheaters can do very well. They reap the benefits of others' cooperation without paying the costs. But if everyone cheats, the strategy fails. This explains why sociopathy persists at low rates, around 1 to 4% of the population. It's a strategy that only works when it's rare. On the other end of the spectrum, obsessive-compulsive personality disorder, or OCPD, involves risk aversion, perfectionism, and rigid adherence to rules. This looks like a slow life history strategy, adaptive in stable, predictable environments where careful planning pays off. Now here's where mismatch comes in. Modern environments may be amplifying these traits into disorders. Social fragmentation weakens kin support, which intensifies the attachment insecurity we see in BPD. Modern hierarchies, with their extreme inequality and visibility of the ultra-successful, amplify narcissistic and antisocial tendencies. Information overload exacerbates obsessive patterns and avoidance behaviors. The key insight is that personality disorders might not be purely pathological. They might be extreme variants of strategies that were adaptive in some ancestral contexts but are poorly suited to modern environments. This doesn't excuse harmful behavior, but it does help us understand why these patterns persist and how we might intervene more effectively. Let's dive into the formal classification of personality disorders according to the DSM-5 TR. Now, I know classifications can be dry, but bear with me because understanding these categories will help us see the evolutionary patterns more clearly. Personality disorders are defined as enduring inflexible patterns of behavior that deviate from cultural expectations and cause distress. Three key features: they're pervasive across situations, stable over time, and cause significant distress or impairment. The DSM-5-TR recognizes 10 personality disorders organized into three clusters. Cluster A is the odd or eccentric cluster, characterized by odd, eccentric, or suspicious behaviors and social withdrawal. Let's go through them. Paranoid personality disorder requires 4 or more of 7 criteria. These individuals show pervasive distrust and suspicion. They read threats into benign events, hold grudges persistently, and are quick to anger or counterattack. From an evolutionary perspective, think about this as an overactive threat detection system. In some environments, high suspicion might have been adaptive, but here it's gone into overdrive. Schizoid personality disorder also requires 4 of 7 criteria. These individuals show detachment from social relationships and restricted emotional expression. They prefer solitary activities and display emotional coldness or flat affect. Evolutionarily, this is puzzling because humans are such social creatures. This might represent the extreme low end of the normal distribution of sociability. Schizotypal personality disorder requires 5 of 9 criteria and involves cognitive and perceptual distortions, eccentric behavior, odd beliefs or magical thinking, and social anxiety with paranoid fears. This is particularly interesting because it's considered part of the schizophrenia spectrum. It might represent a milder expression of the same genetic vulnerabilities we discussed earlier. What's striking about Cluster A is that these disorders involve withdrawal from the social world, which is so fundamental to human nature. These might represent malfunctions in our social cognitive systems, or possibly extreme variants of introversion and threat sensitivity that become maladaptive in their intensity. Cluster B is where things get dramatic, literally. This is the dramatic, emotional, or erratic cluster, characterized by dramatic, emotional, or erratic behaviors, impulsivity, and unstable relationships. These disorders affect about 1.5% of the general population, but up to 30% in psychiatric settings, which tells you something about their severity and impact. Let's start with antisocial personality disorder, or ASPD. This requires evidence of conduct disorder before age 15 and at least 3 of 7 indicators in adulthood. We're talking about disregard for others' rights, deceitfulness and manipulation, impulsivity and aggression, and lack of remorse or empathy. Remember our discussion of frequency-dependent selection? This is your classic cheater strategy. These individuals are often superficially charming, they have to be to successfully exploit others, but they lack the emotional connections that constrain most people's behavior. Borderline personality disorder, or BPD. The core features are frantic efforts to avoid abandonment, unstable relationships and self-image, impulsivity, self-harming behavior, and chronic feelings of emptiness. This is the fast life history strategy we discussed: intense, unstable relationships, impulsive behavior, living in the moment. The fear of abandonment is particularly striking from an evolutionary perspective. In ancestral environments, abandonment could be fatal, especially for women and children. BPD might involve a hypersensitive abandonment detection system. Histrionic personality disorder, or HPD, excessive attention-seeking emotion, inappropriate seductive behavior, shallow and rapidly shifting emotions, and theatrical or exaggerated expression. These individuals need to be the center of attention. Think about this as an extreme version of strategies for attracting attention and resources, taken to a level that becomes counterproductive. Narcissistic personality disorder, or NPD, grandiose self-importance, need for excessive admiration, sense of entitlement, lack of empathy, and arrogant or exploitative behavior. From an evolutionary perspective, this might relate to dominance-seeking strategies. In some contexts, self-promotion and status-seeking are adaptive. But narcissism takes this to an extreme where the person's inflated self-image is disconnected from reality. What unites Cluster B is the intensity, intense emotions, intense relationships, intense self-focus. These might be extreme variants of strategies for attracting attention, resources, and mates, but they're so extreme that they become self-defeating. Cluster C is the anxious or fearful cluster, characterized by anxious, fearful behaviors and excessive worry. These disorders affect 2.7-6% of the general population, making them the most common personality disorders. Avoidant personality disorder, or AVPD, requires 4 of 7 criteria: social inhibition and avoidance, feelings of inadequacy, hypersensitivity to criticism, and, here's what's poignant, wanting relationships but fearing rejection. These individuals desperately want social connection but are paralyzed by fear. From an evolutionary perspective, this might be an extreme version of the behavioral inhibition system we all have. Some degree of social caution is adaptive, but here it's so extreme that it prevents the social bonding that's essential for human well-being. Dependent personality disorder, or DPD, requires 5 of 8 criteria: excessive need to be cared for, submissive and clinging behavior, difficulty making decisions, and needing others to assume responsibility. Think about this in terms of attachment strategies. In ancestral environments, forming strong dependent relationships with caregivers and later with partners was crucial for survival. DPD might be an extreme version of this attachment strategy, where the person never develops autonomy. Obsessive-compulsive personality disorder, and note this is different from OCD, the anxiety disorder, requires 4 of 8 criteria: preoccupation with orderliness, perfectionism that interferes with task completion, inflexibility about morality and ethics. These individuals are so focused on control and perfection that they can't actually complete tasks. Evolutionarily, conscientiousness and attention to detail are generally adaptive traits. OCPD represents these traits taken to a maladaptive extreme. Treatment varies by cluster. Cluster A typically responds to CBT focused on thought patterns. Cluster B often requires DBT, dialectical behavior therapy, or psychodynamic approaches. Cluster C responds well to CBT and exposure therapy. Medications are used only for comorbid symptoms, not the personality disorders themselves. The prognosis is that these are chronic conditions requiring long-term care, but early intervention is key, and symptoms often lessen over time. Many people with personality disorders can improve significantly with appropriate treatment. What I want you to take away from this classification is that personality disorders represent extreme variants of normal personality traits. They're not completely alien ways of being, they're exaggerations of strategies and traits we all have to some degree. Now we're going to step back and look at the big picture with evolutionary mismatch theory. This is really the core framework for understanding why psychological disorders are so prevalent in modern society, and I think it's one of the most important concepts in evolutionary psychology. So what is evolutionary mismatch? It occurs when traits that were adapted for ancestral environments become maladaptive in modern ones due to rapid environmental change. The key insight is that environmental change far outpaces genetic evolution. Our genes are still adapted for the Pleistocene, the period from about 2.6 million to 12,000 years ago when humans lived as hunter-gatherers. But our environment has changed radically, especially in the last few hundred years. Think about it this way. We have Stone Age brains trying to navigate a Space Age world. That's mismatch. Let me break down the 3 components of mismatch. First, the ancestral environment, Pleistocene hunter-gatherer societies. This is the environment of evolutionary adaptedness, the context in which our psychological mechanisms evolved. Second, the modern environment, rapid technological and lifestyle shifts, especially since the Industrial Revolution. Third, trait expression. Adaptive traits become dysregulated when expressed in the wrong environment. Let me give you some concrete contrasts. Activity. Ancestral humans were highly active, walking miles every day. Modern humans are sedentary, sitting for hours. Diet. Ancestral humans ate whole foods: meat, fish, fruits, vegetables, nuts. Modern humans eat processed foods loaded with sugar, salt, and fat. Social. Ancestral humans lived in small kin groups where everyone knew everyone. Modern humans live in anonymous societies where we're surrounded by strangers. Threats. Ancestral threats were acute and immediate: a predator, a storm, a hostile encounter. Modern threats are chronic and abstract: job insecurity, climate change, retirement planning. Sleep. Ancestral humans slept according to natural light cycles. Modern humans are exposed to artificial light 24/7, disrupting circadian rhythms. Information. Ancestral humans had limited relevant information from their immediate environment. Modern humans face constant information overload from global sources. This framework helps explain the high prevalence of psychological disorders in modern society. We're not more genetically vulnerable than our ancestors. We're just living in an environment that's profoundly mismatched with our evolved psychology. This is why understanding mismatch is so crucial for both understanding and treating psychological disorders. Now let's get specific about how mismatch mechanisms operate across different disorders. This is where the rubber meets the road. How do ancestral adaptations become modern vulnerabilities? Let's start with depression. Social defeat responses were adaptive for withdrawing from unwinnable competitions. If you're losing a status conflict, it makes sense to withdraw and conserve energy rather than continuing to fight. But in modern hierarchical workplaces with limited escape, these defeat responses become chronic. You can't just leave your job and join another tribe. Social support seeking was adaptive in ancestral environments with stable kin networks, but it fails in fragmented modern communities lacking stable relationships. And seasonal affective patterns persist but are dysregulated by artificial lighting. Your brain doesn't know it's winter when you're under fluorescent lights all day. Anxiety is a perfect example of mismatch. Threat detection systems evolved for immediate physical dangers, predators, hostile groups, dangerous terrain. These systems fire constantly in response to abstract modern threats like financial insecurity and social status. Social anxiety intensifies with large anonymous groups and digital communication that removes face-to-face cues. And panic disorder involves a mismatch between suffocation alarm systems and modern triggers like enclosed spaces and crowds. ADHD is fascinating from a mismatch perspective. Attention mechanisms that were adaptive for scanning varied hunter-gatherer environments, novelty-seeking, rapid task switching, become disordered in contexts requiring sustained focus on monotonous tasks. Think about a hunter-gatherer child. They need to notice everything in their environment, switch attention rapidly, and respond to novelty. Now put that same child in a classroom where they're expected to sit still for hours and focus on abstract symbols. That's mismatch. Eating disorders show mismatch in striking ways. Anorexia may involve famine response mechanisms, reduced appetite and hyperactivity for food seeking, triggered inappropriately by modern dieting. Bulimia involves binge eating responses to perceived scarcity, followed by modern purging behaviors. And obesity results from evolved preferences for calorie-dense foods meeting constant modern availability. We evolved to crave sugar, salt, and fat because they were rare and valuable in ancestral environments. Now they're everywhere and our cravings haven't caught up. Substance use disorders involve reward systems evolved for natural reinforcers, food, social bonding, sex, being hijacked by supernormal stimuli. Refined drugs and concentrated alcohol are substances that never existed in ancestral environments. Our reward systems have no defenses against them. Finally, bipolar disorder and schizophrenia show mismatch in circadian rhythm disruptions from artificial lighting and shift work triggering mood episodes, and modern urban stress, social fragmentation, and substance exposure interacting with genetic vulnerabilities. Chronic inflammation from modern lifestyle exacerbates neurodevelopmental vulnerabilities. The key insight is that these aren't just broken brains, they're normal brains responding to abnormal environments. Understanding the specific mismatch mechanisms for each disorder helps us develop more targeted interventions. Let's look at the evidence for the mismatch hypothesis. This isn't just theoretical speculation, we have real data supporting this framework. First, cross-cultural patterns. Disorder prevalence is consistently lower in traditional societies and rises with modernization. This is a striking pattern. As societies industrialize and urbanize, rates of depression, anxiety, and other disorders increase. If these disorders were purely genetic, we wouldn't see this pattern. Second, historical trends. Anxiety and depression rates correlate with industrialization, and the increase has been far too rapid to be explained by genetic evolution. We're talking about changes over decades or centuries, not the thousands of years required for genetic evolution. This strongly suggests environmental factors. Third, neurobiological evidence. Modern stressors alter brain regions involved in threat detection, reward processing, and stress regulation. We can see these changes in brain imaging studies. Chronic stress literally changes brain structure and function. Fourth, intervention studies. Lifestyle changes, exercise, nature exposure, improved sleep show efficacy in reducing symptoms. This is powerful evidence because if disorders were purely genetic or biochemical, lifestyle interventions shouldn't work as well as they do. Let me walk you through some specific modern stressors. Urbanization brings social fragmentation and reduced nature exposure. Digital overload means constant social media comparison and fear of missing out. Sleep disruption from artificial light and screen time. Work pressure creating chronic stress and job insecurity. Social isolation with weakened kin support. And diet and lifestyle factors, processed foods and sedentary behavior. There's even a scale called the Evolutionary Mismatch in Lifestyle Scale, or EMLS, that measures mismatch behaviors. Higher scores on this scale correlate with poorer mental health. This gives us a quantifiable way to measure mismatch. But, and this is important, we need to be careful about some implications. Not all modern innovations are mismatched. Some modern developments, like medicine and stable food supplies, actually reduce risk for many disorders. Context is key. Individual variation matters too. Susceptibility to mismatch varies due to genetics, development, and life circumstances. And disorders are complex. Mismatch is one of many contributing factors, not the only explanation. The evidence strongly supports mismatch as a major contributor to modern psychological disorders, but it's not the whole story. We need to integrate mismatch theory with genetic, developmental, and social perspectives for a complete understanding. Now let's talk about the exciting part. How do we translate these evolutionary insights into clinical practice? This is where evolutionary psychiatry moves from theory to application, and I think this represents the future of mental health treatment. Let me start with the core treatment principles. First, distinguish adaptive responses from dysfunctions. Not every negative emotion is pathological. Sometimes anxiety or sadness is an appropriate response to a real problem. Second, identify environmental mismatches as targets for intervention. Sometimes the problem isn't the person, it's the environment. Third, calibrate defensive symptoms rather than just eliminating them. We don't want to eliminate anxiety entirely. We want to calibrate it to appropriate levels. Fourth, integrate genetic, developmental, and environmental factors for a comprehensive understanding. And fifth, reduce stigma with evolutionary explanations. Understanding that depression or anxiety has evolutionary roots can reduce the shame and self-blame many people feel. Let me walk you through some general strategies. Mismatch reduction means aligning context with evolutionary design, improving diet, increasing exercise, optimizing sleep. These aren't just lifestyle factors. They're fundamental to how our brains are designed to function. Defensive recalibration means calibrating, not suppressing, defensive responses. Exposure therapy is a perfect example. We're not eliminating the fear response. We're recalibrating it to appropriate levels. Social integration addresses social systems and community support to reduce isolation. And lifestyle medicine promotes evolved needs as prevention, not just treatment. Now let's get specific with different disorders. For depression, address social defeat by changing environments when possible, and use behavioral activation to re-engage with rewarding activities. For anxiety, use exposure therapy to recalibrate threat detection, plus nature-based interventions to reduce chronic arousal. For autism, use strengths-based approaches and environmental accommodation rather than trying to fix the person. For bipolar disorder, focus on circadian stabilization and social rhythm therapy, regulating sleep-wake cycles and daily routines. For schizophrenia, emphasize early intervention, cognitive remediation, and stress reduction. Here's what's crucial. Evolutionary insights enhance, not replace, existing evidence-based practices. We're not throwing out CBT or medication. We're adding an evolutionary framework that helps us understand why these treatments work and how we might improve them. For example, understanding that depression might involve social defeat responses helps us see why changing social environments can be so powerful. Understanding that anxiety involves overactive threat detection helps us see why exposure therapy works. We're recalibrating the system, not breaking it. Understanding mismatch helps us see why lifestyle interventions like exercise and nature exposure are so effective. We're providing inputs the brain evolved to expect. The future of mental health treatment will integrate evolutionary insights with existing approaches to create more comprehensive, effective interventions. And importantly, this framework reduces stigma by helping people understand that their struggles aren't personal failures. They're the result of Stone Age brains trying to navigate a modern world. All right, we're at the end of our journey through evolutionary perspectives on psychological disorders, so let's synthesize everything and talk about key takeaways and implications. First, the key insights. Psychological disorders are complex outcomes of evolutionary processes, trade-offs, mismatch effects, or mechanisms gone awry. They're not simple broken brain problems. They're the result of complex interactions between our evolutionary heritage and modern environments. Second, these disorders are universal yet variable. Universal evolutionary forces interact with individual genetic, developmental, and life history variation. Every human population shows these disorders, but individuals vary in their susceptibility and expression. Third, this evolutionary perspective is complementary, not competitive. It complements biological, developmental, social, and clinical psychology by providing ultimate explanations, the why questions that other approaches don't address. We're not replacing other perspectives, we're adding a crucial layer of understanding. Fourth, disorders persist through multiple mechanisms. Balancing selection, where genes have both costs and benefits, pleiotropy, where genes have multiple effects, mutation selection balance, where new mutations constantly arise, and rapid environmental change that outpaces genetic evolution. Now, what are the implications? Clinically, this framework provides better understanding of symptoms and onset, reduces stigma through evolutionary explanations, and informs novel treatments like lifestyle modifications. For research, it helps identify genes and mechanisms, generates testable hypotheses, and suggests mismatch reduction interventions to test. For prevention, it points to addressing societal mismatches before disorders emerge. But we need some cautions. Not all modern innovations are mismatched, some reduce disorder risk. We need to avoid oversimplification. True dysfunctions exist that aren't just mismatch. All hypotheses require rigorous empirical testing. Evolutionary explanations can be seductive but need evidence. And cultural variation impacts how universal processes are expressed. Looking to the future, I believe an integrated evolutionary perspective is poised to transform 21st century mental health care by unifying theory and practice. We're moving toward a more comprehensive understanding that integrates evolutionary, genetic, developmental, social, and clinical perspectives. Let me leave you with this thought. Understanding our evolutionary origins helps us appreciate both the mind's remarkable adaptations and the challenges of living in a rapidly changing world. We're not perfectly designed machines. We're the products of evolution with all the trade-offs, compromises, and mismatches that entails. But understanding this gives us power. Power to reduce stigma, power to develop better treatments, and power to create environments that better match our evolved needs. The goal isn't to return to some idealized ancestral past that's neither possible nor desirable. The goal is to understand our evolutionary heritage so we can navigate the modern world more effectively, with greater compassion for ourselves and others who struggle with psychological disorders. Thank you, and I look forward to your questions.